In this video, we're going to talk about trigonometric integrals. So here, we will be discussing some techniques that will allow us to evaluate integrals that involve these general expressions. Okay, so we have products of sine and cosine, powers of sine and cosine. These two expressions are they are different. Itong products of cosine and products of sine and cosine, they involve itong first one, they involve different arguments. Kumbaga, sine, ang argument ng sine is different from the argument ng cosine. And both sine and cosine, they are raised to 1 only. Okay? So, sine raised to 1, cosine raised to 1. But with different arguments. Okay? Ang powers of sine and cosine naman, they contain similar arguments. So, equal ang arguments nila. Equal expressions, same expressions. Kaso, they are raised to a certain power other than 1. Okay? Then, we have powers of tangent and secant, powers of cotangent and cosecant. Okay? So, this will be a two-part discussion. Part 1 will cover first two types of integrals. And then, part 2 ng video will cover the last two na cases. Okay? So, let's start with the first case, products of sine and cosine. So, this will be evaluated using an identity, no? To be particular, product to sum trigonometric identity. Okay? So, again, we have placeholders para sa mga argument. U and V are differentiable functions of x. And I'm sure by now we already know, we already understood this one, na it can be any variable. It can be, I mean, U and V are placeholders, so it can be any expression, and they can be defined in terms of x or in terms of y, in terms of any other variable. Okay? Pero in this case, products of sine and cosine, yan, that's the condition. U and V, meaning ang argument ng sine is not equal to the argument ng cosine. That will make it, kumbaga, this condition makes it non-integrable in the first place. And we have to apply some technique. And the technique is applying identity lang naman. Okay? So first one, if we have product ng sine and cosine with different arguments, then we can use this equivalent expression. Okay? Pag cosine and cosine, but again, different angles, then this one. Pag sine and sine naman, so this one. Okay? Again, these are derived or obtained from product to sum identity ng trigonometric functions. Okay? So in the at first or initially, these three, kumbaga, are non-integrable, no, in its initial form, in their initial form. Okay? After applying product to sum identities, tapos after simplifying, then readily integrable na sila. Okay? So let's try. We have here sine 5x times sine x. So product of two sine functions, tapos different arguments, different angles. So we apply identity. So in this case, product of sine and sine, that would be itong number 3 na formula. So we should use this one, this equivalent expression. So 1/2 cosine u minus v. U in this case is 5x. V is what? X. Okay? So first term, itong cosine 5x minus x, this corresponds to cosine u minus v. And we have minus cosine 5x plus x. Ito naman, it corresponds to the second term ng formula. Okay? So simplify lang, and then we now have 1/2 integral of cosine 4x minus cosine 6x. These are integrable na ng mga terms. Okay? We just apply u sub for the arguments. So first term, isolate natin ang first term. Cosine 4x, let u be equal to 4x. So du is what? for dx. Okay? And then second term, u sub pa din. Pero in this case, u is 6x. So du is what? 6 dx. Okay? Then don't forget, we applied u sub, so you can just apply it as is, retain the original variable x. So don't forget to incorporate the neutralizing factor. Or this will be automatically generated, the constants, no? Yung neutralizing factors, I mean, if we express the original integral in terms of the new variable na u. Okay? So after applying u sub, and of course, integral ng cosine is positive sign. So this will give us this expression. Okay? Or we can write the expression in this way, in this form. So pwede na ito. Or we can distribute 1/2. Okay? Next. Next, we have here integral of sine 4x minus 3 cosine x plus 5 dx. Okay? So product of sine and cosine, that would be number 1. So we will be using this expression, equivalent expression. Okay? So 1/2 sine u plus v. U in this case is 4x minus 3. V is x plus 5. So add the two terms, add the two arguments for the first term. And then take the difference for the second term. So sine u minus v. Okay. Then simplify, combine like terms. Then again, u sub. So first term, u is 5x plus 2. Therefore, du is 5 dx. Then second term, u is 3x minus 8. So du is 3 dx. Oops. Okay. Then, integral ng sine is cosine. I mean, negative cosine. Alright? So, after applying u sub and integral ng sine, this will give us this expression. Okay? And then, simplify lang, we can, again, we can distribute 1/2. And this is now our final answer. Next. So we have here cosine 3x minus 2 pi times cosine x plus pi. So we have here, if we look at the arguments, we have here special angles. Okay? 2 pi and pi. If merong involved na special angle, we should evaluate them kasi special angles, pwede man sila i-evaluate, no? Without calculator. If you can still recall sa unit circle. Okay, so we evaluate them. It's either before applying the integration process or after the integration process. Okay, so what I did here, nag-evaluate ako before sa integration. Okay, so how do we evaluate this one if naka-separate into terms ang argument? We can apply another identity, no? Sum of two angles na identity. In this case, for cosine. Okay, so that's what happened here sa ito na line. Okay, so again, I used the sum of two angles na identity for cosine. So if we have cosine of alpha plus minus beta, then the result is this one. Cos, sin, sin. Okay, so pag the two terms are, if sum of two terms ang angle, ang argument, then the corresponding na identity should be difference of two terms. Okay, that's what it means if we say plus minus tapos ang ihang corresponding na identity is minus plus. Okay, so pag sum of two angles, the corresponding identity should be difference of two terms. Pag difference of two angles naman, the identity should be sum of two terms. Okay? So for example, this one, difference, ito first term. So difference of two angles siya. Therefore, its corresponding identity is sum of two terms. Okay? So cosine 3x, cosine 2 pi, again from this identity, plus sine 3x, sine 2 pi. Okay? And then, itong second cosine factor is sum, right? Sum of two angles. Pag sum of two angles, the resulting identity or the corresponding identity should be difference of, diba? Should be difference of two terms. Okay. So again, we have here cosine x times cosine pi minus sine x sine pi. Okay. So we now have individual trigonometric function values for the special angles. Okay. So cosine 2 pi is a quadrantal angle. If we measure 2 pi na angle, its initial side, diba? If we measure standard angles, kumbaga, initial side is on or coincidental or coincides with the positive x-axis, tapos ang terminal side is anywhere in the Cartesian plane. Tama ba? So ang 2 pi, ang iyang terminal side is the same sa initial side na sa coincidental sa positive x-axis, diba? 360 degrees, kumbaga. Kasi that's the degree equivalent ng 2 pi. So, its terminal side is on the positive x-axis. So, ang corresponding na ordered pair is 1, 0. Therefore, cosine 2 pi is the x-coordinate ng 1, 0. Therefore, cosine 2 pi is 1. How about sine 2 pi? Sine 2 pi naman, so same ordered pair, diba? 1, 0. Kaso pag sine, that's the y-coordinate naman. So, pag 1, 0, y-coordinate is 0. Therefore, sine 2 pi is 0. Or if you have calculator, pwede nyo i-check sa calculator, class. But basically, that's how we evaluate trigonometric function values for special angles. Okay? Refer lang sa unit circle. Okay? And then cosine pi, this is another, ang pi is another quadrantal angle. No? So again, measuring standard positioned angles, initial side is on the positive x-axis, tapos we move counterclockwise, diba? Therefore, terminal side can be anywhere in the Cartesian plane. Pag pi, its terminal side is on the negative x-axis. Okay? So, kumbaga, 180 degrees from the positive x-axis, going counterclockwise. 180 degrees. Kasi 180 degrees, that's the degree equivalent ng pi, di ba? So, cosine pi, ang corresponding na ordered pair sa unit circle is negative 1, 0, kasi nga nasa negative x-axis siya. So, negative 1, 0, pag cosine, x-coordinate ng ordered pair. Therefore, cosine pi is negative 1. And then, sine pi, yung y-coordinate naman ng negative 1, 0. So, sine pi is 0. Okay. Then, simplify lang. Itong first na factor, mag-0 itong second term. Okay. So, maiwan na lang is cosine 3x times 1. Okay. Ayan, cosine 3x na lang. And then, second na factor, ito, mag-0 itong sa second term. So, maiwan is cosine x times negative 1. Kaya, naging negative cos x. Okay. So, ayan. So, simplified na, kumbaga, ang ating integrand. So, maging ano siya, negative cosine 3x times cosine x. So, product ng cosine, dalawang cosine functions, pero different arguments. So, cos, itong number 2. Right? So, equivalent expression is 1/2 cosine, sum of the two arguments, so 3x plus x, plus cosine, tapos difference of the two arguments. Okay? So, simplify lang. And then, u sub. First term, u equals what? 4x. So, du is 4dx. And then, second term, u in this case is 2x. Therefore, du is 2dx. Okay? So, apply u sub, apply the corresponding neutralizing factor, or you can express everything in terms of u para automatically ma-generate ang extra na factor, na constant factor. And then, of course, integral of cosine is positive sign. Okay? So apply the formulas and then simplify. So you can write this in this form, the final answer, or we can distribute negative 1/2. Okay, so this can be now a final answer. Okay, so let's proceed to the next type of trigonometric integrals. So kumbaga yung sa powers of sine and cosine. So this is different again from the previous na case kasi in this case the same arguments na, same expressions na ang argument ng sine and cosine. Kaso they are raised to, both sine and cosine are raised to a certain power that is kumbaga other than 1. Okay? So raised to any real number other than 1. Okay? And then first case for this one, subcase for this one is ayan. So ito dapat ang form ng integral. Sine raised to m, which is any real number of x, tapos cosine raised to n of x. Again, n is any real number also. Okay? And then ang first case is if m, yung power ng sine, is a positive odd number. So ito ang bantayan na to. If the power of sine is a positive odd number, tapos ang power ng cosine is any number, meaning any real number, it can be positive or negative, basta kay any number. It can be a fraction. Okay? So regardless kung anong klaseng number, basta real number siya. Okay? Then what do? We save one sine factor. So kumbaga from sine raised to m of x, we factor out isang sine na function. Okay? And then the remaining na sine factor should be converted to cosine. Okay? So let's see. So ayan. So focus tayo sa first na portion. Ito sa pinaka left hand side. Okay? So nangyari dito class, itong 2k plus 1, this is initially m, di ba? Power ng sine. So ito lang para ma-emphasize na it's an odd number, positive odd number. Kasi whatever the value of k is, if we plug in any positive integer sa k, so 2 times that positive integer tapos plus 1, it is an odd number. Diba? Para ma-emphasize lang na it's an odd, positive odd na integer. Okay? And then, of course, n, power ng cosine is any real number. Okay? So what do we do again? Save one sine factor, meaning we factor out isang sine. So nangyari, from sine raised to 2k plus 1, factor out one sine function. So yan, nag-factor out ng sine. Maiwan is sine raised to 2k of x, which can be written in this form. No? Nakahiwalay ang kumbaga nag-factor out ng k. So maging siya, sine squared of x raised to k. Okay? So that we can convert itong sine into cosine by using Pythagorean identity. Okay? Convert to cosine again using Pythagorean identity. So from sine squared x naging 1 minus cosine squared x na siya. Raised to k. So if for example ang k is 2, then expand nyo lang 1 minus cosine squared x raised to 2. Expand lang. And then distribute ang cosine. Okay? After na-distribute ang cosine, we now have sum of powers of cosine times sine x dx. Tapos u sub na lang, u equals cosine x, du is sine x dx. That's why we factored out sine x, kasi we will be using sine x dx later on para ma-satisfy ang du. Okay? So this is now our working expression for this case of power of sine and cosine. Okay? So again, after na-expand itong 1 minus cosine squared x raised to k, distribute ang cosine raised to n of x, tapos u sub na lang. Okay? So let's have an example. This one. Sine cube of x cosine squared x dx. So ang bantayan natin class if which exponent ang positive odd number. So, ang first case is if power ng sine ang positive odd number, which is the case for this example. Okay? So, sine cube x, cosine squared x dx, ang power ng sine ang positive odd. So, we factor out one sine. We isolate one sine factor. Ayan. So, from sine cube x, naging sine squared x, and yung sine x dx. Okay? So, na-isolate lang isang sine x. Tapos, from sine squared x, Pythagorean identity, excuse me. So, we apply Pythagorean identity to convert sine to cosine. Ayan. And then, distribute lang cosine squared x. So, this will give us cosine squared x minus cosine raised to 4x, tapos sine x dx. And then, from here, apply na lang na u sub. Okay? Let u equals cosine x, for which ang du is what? Negative sine x dx. Okay? So, meron na tayong sine x dx. We just have to multiply negative 1 para maging negative sine x dx. And of course, neutralizing factor, negative 1. Okay? And this is now integrable using power rule. Okay? So, maging ano siya? U raised to 3 over 3, where u is cosine x para sa first term. Tapos u raised to 5 over 5 para sa second term. Again, u is cosine x. Okay? So, this is now final answer. Or, pwede nyo i-distribute ang negative 1. Okay? Next, case 2, the same concept sa first na case, subcase for itong powers of sine and cosine. Kaso instead of power ng sine ang positive odd number, in this case, power naman ng, or exponent naman ng cosine ang positive odd number. So, the same concept ang i-apply natin, class. Instead of sine ang i-factor out, in this case, ang cosine ang i-factor out or ang i-isolate. Okay? Para magamit for du later on. Alright. So, again, yung itong 2k plus 1, initially, diba, this is n. Para ma-emphasize lang na it's an odd number. Okay? So, you take out one cosine factor. So, from cosine raised to 2k plus 1, isolate 1 cosine x, kaya naging cosine squared. After nag-isolate, maging ano siya, diba? Cosine raised to 2k of x. Tapos, yung cosine raised to 2k, so sulat na ako, cosine raised to 2k of x. This can be written as cosine squared x raised to k. Okay? Baga na-separate lang ang 2 times k. Alright? And then, from here, itong cosine squared x, so, erase na to. Again, same concept from the previous na case. Itong cosine should be converted to sine using Pythagorean identity pa rin. Okay? So, from cosine squared x, naging 1 minus sine squared x. And then, raised to k, expand lang. Whatever the value of k is, expand lang and then distribute ang sine raised to m of x. So, we now have sum of the powers of sine times cosine x dx. Okay? And then, u sub u in this case is sine x, du is cosine x dx. So, integrable na siya. Okay? So, again, yung cosine x na factor out initially will be used for du, to satisfy du after nag-u sub. Okay? So, this is now our working expression, equivalent expression. Then, just distribute sine and then apply u sub. Alright? So, let's look at an example for this case. We have here integral of cosine raised to 5x divided by square root of sine x. So, first we can rewrite muna so as to follow the form sine raised to m of x, cosine raised to n of x dx. Okay? And then, check ninyo ang exponents. So, again, ang determining factor is which of the two exponents ang positive odd number. Okay, so in this case, ang positive odd na exponent is ang sa cosine. Okay, so we factor out or we isolate one cosine factor. Okay, so this will now result to this form of the integral. So again, itong sine sa baba, square root of sine x can be written as sine raised to negative 1/2 x. Okay, and then yung cosine raised to 5x dx, nag-isolate lang ng isang cosine x, kaya naging cosine 4x. I mean, cosine raised to 4x times cosine x dx. Okay, and then itong cosine raised to 4x can be written as cosine squared x raised to 2. Tama ba? And then cosine squared x, using Pythagorean identity, can be written as 1 minus sine squared x. Okay, and then expand 1 minus sine squared x raised to 2, expand, and then distribute sine raised to 1/2 x. I mean sine raised to negative 1/2 x. Okay, so yan, after na distribute, we can now apply u sub, right? So u in this case is sine x, diba? And then du is what? Du is negative cosine x. Okay, so we need negative 1. Okay, multiply negative 1. Then of course, neutralizing factor is negative 1. Okay. Derivative pala. Sorry, mix up. Positive dapat. No, kasi nag-differentiate, nagkuha mo ng differential. So ayan. So sin x, its derivative is cosine x. Positive cosine x dapat. Okay? So diretso na. Apply power rule. Negative 1/2 plus 1, that's 1/2 divided by 1/2. So simplify lang. Then 3/2 plus 1, that's 5/2. So raised to 5 over, sine raised to 5/2 divided by 5/2, tapos simplify lang. And then 7/2 plus 1, that would be 9/2. So this will be divided by 9/2. And then simplify plus c. This is now our final answer. Okay. And then case 3 for powers of sine and cosine. This time, kasi okay na, we already covered the cases for which positive odd ang sine or positive odd ang cosine. This time, what if they are both positive even naman? Positive even numbers. Both of them are positive even numbers. They don't have to be equal, pero they have to be the same na positive even numbers. Okay? So if that's the case, then we can make repeated use of power reducing identities. Repeated kasi we will be applying this, or we will be using this identity more than once. Okay? If applicable. Okay? So ito, power reducing identities, these are derived or obtained from double angle identity ng cosine. Okay? So let's try using these identities. We have here sine raised to 4 of x, cosine squared of x. Both are positive even numbers. Tama ba? So if that's the case, then we can apply power reducing identities. Pero before we can apply power reducing identities, para mas dali, para mas convenient class, kasi if we do this any other way, medyo complicated siya. Okay, so what I did here is para mas convenient siya i-solve, para mas, kumbaga, relatively easier siya i-solve. Okay, so before we apply identities, we can simplify this by writing sine 4x, rewriting sine 4x, I mean rewriting sine raised to 4x as product of sine squared x and sine squared x. Okay, and then itong sine squared x and cosine squared x, i-group natin siya. Okay, kasi same ang powers, so we can factor out the power. Tama ba? And then after factoring out the power, ang sine x, cosine x, kasi merong identity, di ba? And then itong naiwan na sine squared x, apply power reducing identity immediately. So, naging 1 minus cosine 2x over 2 siya. And then, initially from sine squared x, cosine squared x, kasi same ang exponent, we can factor out the exponent. And then sine x, cosine x, if you can still recall, we have an identity for this one, di ba? This is equivalent. This can be written in its equivalent expression using double angle identity ng sine. Tama ba? So yan, naging sine 2x over 2 siya. This is from double angle identity ng sine. Okay? So, itong 1/2 sa first na factor, nag-factor out lang ng 1/2. Okay? And then sine 2x raised to 2, sine of 2x divided by 2. Everything is raised to 2. So, we can redistribute the power. Okay? So, that maging siya. Sine squared 2x divided by 4. Tapos, itong 1/4, we can take out 1/4. We can factor out 1/4. Right? So, we now have 1 minus cosine 2x sine squared 2x. So, itong sine squared 2x can be written in its equivalent expression, again, using power reducing identity. Okay? So, remember lang na 2x na this time ang argument. So, power reducing, which is derived from double angle. So, itong 2x, after applying identity, dapat maging siya? Maging 4x. Okay? So, refer lang sa identity. Ayan. So, 1 minus cosine 4x divided by 2. And then again, itong 1/2 factor out. So, again, itong 1/2 factor out. Ayan. So, we now have product of 1 minus cos 2x, 1 minus cos 4x, and then expand. Okay. So, ayan. This is now the expansion. 1 minus cosine 2x minus cosine 4x plus cosine 4x cosine 2x. So, itong cosine 4x cosine 2x, remember sa first part of the discussion, di ba, yung product of sines and cosines. So, this one can be written in its equivalent expression using product to sum na identity, di ba? So, product of two cosine functions, kaso different arguments. So, this is equivalent to 1/2 cosine 4x plus 2x plus 1/2 cosine 4x minus 2x. Kaya naging 6x and 2x ang argument. Okay? So, ito siya is equivalent to these two terms. Diba? Okay? And after this one, ito na line is all the terms in this line are integrable na. Okay? So, you just apply separate na u subs for cosine 2x, cosine 4x, cosine 6x. Pero itong cosine 2x pala, we can combine this to itong negative cosine 2x. So, negative cosine 2x and positive 1/2 cosine 2x. So, i-combine lang. Ayan. And then u sub. So, itong sa second term, let u be equal to 2x. Ang sa third term naman, u is 4x. Tapos, ang sa last term, ang u ay 6x. Okay? So, you apply the corresponding na u substitutions lang for the three terms. And then, the result is this one. Okay? Sige. Alright, so next, we have some reminders when using the corresponding techniques for powers of sine and cosine. Kasi we already covered if the power of sine is positive odd, or if the power of cosine is positive odd, or both the powers of sine and cosine are positive even numbers. So now, what if both of them are positive odd numbers? Okay, so we have some sub cases again for this case. Okay? If they are equal, if for example both of them are raised to 3, that's positive odd, then we can either use first and second guideline. Kasi either way, similar, equal level of difficulty lang naman. Kasi nga equal lang ang powers. Same ang powers na positive odd. Tapos equal lang. Okay? Ang problema is if one exponent is greater than the other. Okay? So kumbaga if m is greater than n or n is greater than m, pero both of them are again positive odd, then what do? We base what guideline we use on the smaller na exponent. Okay? Kung saan mas gamay na exponent. Okay? For example, if m, power ng sine, is greater than n, then we base our we use the guideline for cosine. Okay? So we factor out cosine kasi mas maliit ang power ng cosine. Ang determining factor kasi nito is after nag-transform ng integral, it will result to fewer number of terms after nag-expand. No? So for example, integral of sine raised to 7 of x tapos cosine raised to 5 of x dx. Okay? So both powers ng sine and cosine are positive odd numbers. Kaso power ng sine is greater than the power ng cosine. Okay? So what if we use the first guideline, meaning ang basis ang sine. So we take out one sine function. So itong raised to 7 maging raised to 6 na lang, di ba? Cosine to the 5th power of x. And then ang sine raised to 6, that would be sine squared x raised to 3, di ba? Tapos cosine raised to 5x sine x dx. So mangyari class, kasi itong sine squared x gawin natin cosine, di ba? Using Pythagorean. So maging 1 minus cosine squared x. Tapos raised to 3. So it will result to what? It will result to 4 terms. Okay. As opposed to using cosine or basing the transformation on cosine. Okay. So let's try sa cosine. This will result to a fewer number of terms after the expansion. Kasi sine raised to 7 of x cosine raised to 4 of x cosine x dx. Okay? And then ang cosine raised to 4 maging cosine squared x raised to 2. Tama. Tapos ang cosine squared gawin natin 1 minus sine squared, pero raised to 2 lang. So raised to 2 ang expansion. 2 ang exponent for the expansion. So 3 terms lang ang resulting na expansion. Okay? So it will result to fewer terms. So kumbaga mas simpler ang resulting na expression as opposed to kung ang basis natin is ang itong sine. Kumbaga in general, kung ang basis natin is yung yung bigger na exponent. Okay? So again, if both the powers ng sine and cosine are positive odd numbers, tapos one exponent is greater than the other, then we base our solution on the smaller na exponent. Kasi it will result to a fewer number of terms after the expansion. Okay? Yan. Now, if equal naman ang m and n na equal to 1, then this will make everything a lot simpler. No? Kasi we can just simply apply u sub. It's either u equals sine, tapos ang du is cosine x dx. So, okay na, perfectly satisfied na ang u and du. So, power rule na lang diretso. Or, other way around, u equals cosine x, du is negative sine x dx, tapos power rule again. Diba? Or, double angle identity, kaya bahala, depende. Alright? So, that's powers of sine and cosine.